Hello class and welcome to today's lesson for 3-4. Again, like always, if you need to pause and stop the video to catch up, please do that. Free to do that at any time. So today, 3-4, parallel and perpendicular lines. Today's goal, use parallel and perpendicular line theorems. Our essential question is, how can we relate parallel and perpendicular lines? So our first one, we're talking about three lines here. We are told that line A is parallel to line B. So what I'm going to show is by putting our arrows here, line A and line B are parallel to one another. We are also told that line B is parallel to line C. So I'm going to show that with two arrows. Line B is parallel to line C. What it's asking us is, what do we know about lines A and C? And right, if we think about this, right, we think if A and B are both parallel to each other, and then B is also parallel to C. This is kind of like the transitive property, right? A is parallel to B, B is parallel to C. Well, let's cut out that middle piece. We can then just say, oh, well, A is also going to be parallel to C. Right? If they're parallel to the same line, they're going to be parallel to one another. So that's what this talks about right here. If two lines are parallel to the same line, if two lines are parallel to the same line, then they are parallel to each other. So parallel to the same line, they are parallel to each other. Now we have this, we are told line A is perpendicular. Right? If we don't know what this means, right, perpendicular means they cross at a 90-degree angle. 90-degree angle where they cross. So line A is perpendicular to line B. We are told line C is also perpendicular to line B. So we're going to draw a picture, we're going to add in line C to this picture. So we have some line C here that is also perpendicular to line B. It's asking us, what do you know about lines A and C? Well, let's think about this, right? Line A is creating a 90-degree angle with this line B. Line C is also creating a 90-degree angle with line B. If they're creating that same angle, they're at that same distance, or same angle measurement, right? It's safe to assume that those angles or those lines are never going to cross each other. And that's what this next theorem says. That if two lines are perpendicular to the same line, they are perpendicular to the same line, then they are parallel to one another. Two lines are perpendicular to the same line, then they are parallel to one another. What we're going to do is we're actually going to prove this with a proof here. So on this next slide, what I'd like you to do, right, going through these notes, just pause the video and try to complete this proof with the information I give you, and then you can watch and see us solve this proof. So right, pause the video, try to solve this proof with just the information that's given to us, and then you can restart it and we'll talk through it. So talking through this proof, we look, right, we're given that A is perpendicular to C and B is perpendicular to C, so our reasoning here is that it's given. Our reasoning here is that it is given to us. So now what we have to think about is, okay, what does it mean to be perpendicular? Well, if we look at those numbered angles in our picture over here, right, we can say angle 1 and angle 2 are right angles. Right? They are right angles because that's what it means to be perpendicular. That means those lines cross at right angles. Right? They cross at right angles. Well, now let's think of that. What does it mean to be a right angle? All right, hopefully we know to be a right angle, that means the measure of angle 1 has to equal 90 degrees. And that means the measure of angle 2 has to equal 90 degrees. right? So those two angles both equal to 90 degrees. The measurements of those angles are the same. What we can now do is say, okay, angle 1 is congruent to angle 2, because that's what it means to be congruent. Right? If the measurements of two angles are the same, well, that means they are congruent to one another. They are congruent to one another. And so now if we look at the picture up here, right, noticing what type of angles angle 1 and 2 are, right? If we think about angle pairs, looking at those two intersections, right, notice angle 1 and angle 2 are in the same spot. They are what we call corresponding angles. And so, right, our definition or our reason here why we know these lines are parallel, right? When we are trying to prove lines are parallel, we're often using a converse of something. In this case, it's the converse of corresponding angles. Postulate. Right? It's the converse of corresponding angles. The converse of corresponding angles. Because angle 1 and angle 2 are in the same position, so we call them corresponding angles. So moving forward here, again, if you need to pause it, please do. Our next one, we are told line A is perpendicular to line B. Right? So again, that vocab word means that this is a right angle. Now we are told there's a line C that is parallel, do my best to draw a parallel line there, to line B. Parallel to line B. So what we're asking ourselves now is, what is the relationship between A and C? And hopefully we think, right, if B is perpendicular to A, and then C is parallel, right, parallel to B, this angle is also going to be 90 degrees. Right, that angle is also going to be 90 degrees, and that's what this theorem gets at, is that if a line is perpendicular to one of two parallel lines, it is perpendicular to the other one as well. So right, it's perpendicular to one of parallel lines, it is going to be perpendicular to that other parallel line as well. So that is it for today's notes on 3-4, talking about parallel and perpendicular lines.